In this video, I'm going to walk you through a solution to problem 5.9 from our text. The assignment in 5.9 is to create a multi-configuration drawing of the model that we just finished creating in problem 5.8. As a reminder, that model is a I-beam, a W-series I-beam with 4 different configurations, ranging in height and width based on information in the design table that we created. So now we're supposed to create a drawing that represents all those configurations in one drawing. You went through an exercise in the chapter this week that showed you how to do that for a socket head cap screw, and this is going to be a similar process to do it for this I-beam. So first step, as in any drawing, is to make a new drawing from the part and assembly. And I'm creating a new one using my sheet format. And it will ask me what view I want to bring in. So in this case, the length of the part is unchanged for all views, so I'm going to create a front view. Will be my main view that I'm going to dimension and reference the dimensions in the design tables. Then I'll also just add a projected isometric view. I'm just kind of showing a different perspective of the shape. Looking at the scale here, my sheet scale is 1 to 12 and it's clearly smaller than it needs to be. So I will change my sheet scale. Let's try maybe 1 to 8. See what that looks like. Yeah, it can definitely fit that. I could maybe go bigger, but I'll leave it at that for right now until I get the design table in there. Let's take a look also at which configuration this drawing is representing. And that's shown right up here at the top, and it's showing the biggest version right now, so that's fine. I'll leave it like that. So now the next step is to go back to the design table and edit it so that it looks how we want it to. So to do that, I'm going to open the part that the design table is in, and then I'm going to edit the design table. I can do that either in my part here. It'll open up a kind of Excel window within my part, or I can open it as a separate window and then it actually starts Excel. We'll start out here doing it in the part and see how far we get. We might need to change that to make things a little easier to work in. Sometimes it's crowded working in the sheet here in the part file. So here is our sheet format. Our design table. Let's go ahead and just insert it into our drawing before we edit it so we can see why we need to edit it back in the drawing. So to add a table, I go to Annotations, and then here at the end you can see there's Tables. So here's my design table added in, and drag it over. And you can see it's too big, it doesn't really describe the dimensions. So I clearly need to edit the design table to make it fit better. So this is where we'll go back to our part and make all those edits to the design table. So this time I'm going to edit it in a new window. First thing I'm going to do is hide these first 2 rows because they're not very descriptive of what I have going on. I can't delete them because those are the names. Oops, that was accidentally inserted instead of hiding. I can't delete these because these are the names for the different parameters in my part file. So if I delete them, the design table won't work with my part file anymore. So I'm just going to hide those rows. And then I'm going to insert a new row where I will put in labels that I want to use for each of these columns. So this first one, looking back at the table in our book from problem 5.8, this one is our depth of the beam, represented by a D on the drawing. The second one, this is 0.4 to 0.94. That would be the flange thickness, and it's represented by a capital T. The next column, 0.3 to about 0.59, that's the web thickness. It's represented by a lowercase t. And then last one is 6. That's going to be the width. I call that flange width, represented by a B. Okay, and you can see that they're rotated. If I close this and go back to the drawing, we'll see that those labels that I just created, if I rebuild here so that the design table updates, you'll see that my new labels will show up, but they'll be rotated like this, and that's not really how I want them to be viewed. So once it finishes updating, so you can see my new text is in there, but it's rotated kind of confusingly. So let's go back to our part again and edit the design table. So this time I'm going to try to get all of the format done nicely before we go back to the drawing again. So first off, let's select this whole row and adjust the rotation of it. So if we go to Format Cells and look at the alignment, we can rotate our text to horizontal, wrap text so that multiple lines will wrap around, and I'm going to put the vertical alignment at top so that if there's a single line, it'll be at the top. Then I'm going to adjust my column width so that it fits in, each one fits within 2 lines. And then if you double click at the bottom of it, it will automatically adjust the row height. Okay, so there I have all of them. And now I'm going to center the text horizontally. That looks good. And I'm not going to label this last column. You can see that none of the configurations vary in the length of the part. So I don't really need to show that. So I'm actually going to hide that column as well because it's not useful information. Okay, last thing I want to do format-wise, I can narrow this up a little bit so I'm not wasting space. If we look at the decimal points of some of the dimensions, they are less than the actual dimensions were. For example, the flange thickness and flange width and web thickness all have 3 decimal points worth of information. So let's go ahead and increase all of those by 1 decimal point. Okay, and in the depth, it's only to 2 decimal points, so I'll just leave it as it was. Oh, and I'll go ahead and center all of these as well, so that not sure why. Let's try that one more time. Format cells, horizontal. Let's just center. Say okay. It's interesting. It's not. It doesn't look like it's centering. Something about format there, but that's fine. Okay, let's close that now and take a look at our drawing and rebuild so that the design table updates. Okay, we're getting closer. Our text now looks good. I'll bring it inside the border, but you can see the box for the design table is way too big, and if I drag the size, it just scales it. It doesn't actually adjust what's in the view. So to fix that, so let's go back, reset size. To fix this, to actually edit what shows within the view here, again, I have to do that in the part, editing the design table. And this is one place where it's easier to do it when you edit the table in the part file. I'll wait for it to open here. Okay, so here now, if I use these bars on the side to adjust what shows, it will change the appearance correctly. Oops, I went one too far there. Missing. There we go. Okay, so now if we go back to our drawing, it should look nice, the design table. Rebuild. Okay, so now you can see the design tables there. The precision is what I wanted it to be for these 3 columns and 2 decimal places on this column. So last thing we need to do is create dimensions on the shape here that we can reference using D, T, T, and B. So I'll go ahead and I'll right click on my view that or just select the view that I want to import my model items into. Remember, we always try to import model items so that they're tied when possible. In this case, we're going to break the link to them anyways, but that's still just a good habit to do. So let's go ahead and bring those in. Okay, so now I have my dimensions. You can see the front of the dimension has my text from up here, And that's fine, but actually what I want to do is get rid of the numbers because I want these to be general representation of basically the flange width of being B. I just want it to show B, and then the customer would look up at the table to see what B is for the different configurations. So if I select that dimension and then come over here, you can see in the dimension text it says B and then the code for the dimension. So if I just get rid of that DIM, and now it has just B. And do the same thing for all of them. Get rid of the automatic dimension value. Okay, so now I have a drawing that references the design table above using the variables B, D, capital T, and lowercase t. And my dimensions are showing as black here. Yours probably are showing as fuchsia. If this is the first time you've created a drawing with a design table in your text, it showed you how to change that from representing as fuchsia color to black. So I'm going to leave that for you to remember how to do from your text, or if not, go back and read that section again. But so now I have a drawing that represents, this would be considered a multi-configuration drawing. I have a view that's dimensioned using variables that then I reference in my design table so that a customer could figure out the flange thickness, the flange width, the total depth of the beam, and the web thickness from this one drawing for our 4 configurations. I hope that helps.